Hey there, geometry kids. This is Mr. Duffield here doing a presentation on quadrilaterals. You may ask, what is a quadrilateral? Well, when you look at the prefix, a quad means four, lateral means side. So we are looking at figures that have four sides in this new unit. So we'll be looking at laws, theorems, and properties. So let's proceed. First off, we have the angle sum property of quadrilateral. That property is, as you can see, the sum of the angles in a quadrilateral will add up to 360 degrees. So if you look at the figure, as you can see, we have quadrilateral ABCD, and we're trying to prove that angle A plus angle B plus angle C plus angle D equals 360. Well, we know that in a triangle, the three angles in a triangle always add up to 180 degrees. So we have a triangle ADC. We know that's 180 degrees. And we know that triangle ABC is 180 degrees. When you put those two triangles together, we then therefore have proven that the sum of the angles in that quadrilateral is 360, because 180 plus 180 is 360. So let's put that angle sum property to use and look at an example. So here we got a quadrilateral, and we have some angle measures, and we need to set up an equation. So we'll say that 89 plus 5x minus 8 plus 3x plus 4 plus 51 equals 360. We need to combine like terms. So once we simplify that and combine like terms, we get 8x plus 136 equals 360. Again, combining like terms, that gives us 8x equals 224. And then when we simplify for the answer, we get x equals 28. So we've now used the angle sum property to solve for a variable. Length of quadrilaterals, side lengths. So in your note sheet with regards to all the different types of quadrilaterals, we have established what type of relationship sides have. So that's the first thing that we need to do is look at this figure, and here we have a parallelogram. We need to find what's the relationship of the sides, whether they're congruent, if the sides, one side is double the other side, or if one side is half, or if they're an average. Well, in this case, they are congruent. So we're going to set our equation. Our equation will be that 3x plus 5 equals 6x minus 10. Well, combine like terms and solve for the variable. Turns out that x equals 5. Now, on to unknown angles of a quadrilateral. So again, what we want to do is figure out what's the relationship of the angles. So once again, we have a parallelogram. I know that based upon our fact sheet that in a parallelogram that consecutive angles or same side angles are supplementary, which means they add up to 180 degrees. So sometimes they're congruent, sometimes they're supplementary, sometimes they're complementary. In this case, as I said, that they are supplementary. So let's set up our equation. We will say then that 5x plus 2x plus 12 equals 180. Combine like terms and solve for the variable, and it turns out that x equals 24. Now, another problem you may find is finding the segment length of a quadrilateral. So we have a small segment here in this kite, and again we want to figure out what the relationship of the segments, whether they're congruent, double, half, average, whatever the case is. Well, in kites we know that the diagonals, or specifically the long diagonal of a kite, bisects the short diagonal. So that means that the two smaller pieces, the 15, equals the 2x minus 7 in terms of length. So therefore we can set our equation, and then we can solve for the variable. X ends up being 4. Sometimes when we're finding a segment length, we may need to use some of our previously learned knowledge. So here we have a rectangle, and we're trying to solve for x. In this case, we need to determine if we're going to use the Pythagorean theorem, or the knowledge we know about special right triangles, or possibly a trig ratio to figure this out. So in this case, it's the Pythagorean theorem, so we know that a squared plus b squared equals c squared, or in this case, 12 squared plus x squared equals 13 squared. When we solve for the variable, combining things, we get 144 equals x squared, it's 169. X squared would then equal 25. Therefore, x equals 5. Another type of segment you may need to solve for is finding the mid-segment of a trapezoid. So trapezoids are kind of unique because they have a mid-segment, and we've learned about mid-segments within triangles. This is different than within triangles. The property states that the length of the mid-segment, so x in the figure, is equal to the average of the two bases. So remember, when we find the average of something, we add all the numbers up and then divide by how many numbers we added. That's how you find the average. So in this case, we're adding 2 numbers, so we'll be dividing by 2. So the average would be found by 21 plus 35 divided by 2 will give us what x equals, or that mid-segment. When we do the math, x ends up being 28. So good way to check your answer is to make sure that the mid-segment is less than the longest base, but greater than the shortest base. And 28 is greater than 21, and it's less than 35. So that answer makes sense. Looking at a practical sense where we have variables, again, we're going to set our equation. So in this case, we're going to say that x plus 3 plus 4x plus 7 divided by 2 equals 15, because we know what the mid-segment is, but we're trying to solve for the variable x. Well, simplifying that, we combine our like terms. That would give us 5x plus 10 divided by 2 equals 15. I want to get rid of that divided by 2, so I multiply both sides by 2. So that would give me 5x plus 10 equals 30. And then we simplify that. 5x equals 20. And then finally we solve for the variable. X ends up being equal to 4. So that completes our notes on finding the different types of angles or sides or segments within quadrilaterals. You can now proceed on to the assignment. Good luck.